Good day everyone, I am Chewing Tin from Group 16. Today, me and my group mates want to present and discuss about the topic of electrochemical sensors. Group 16 consists of me, Chewing Tin, as a group leader, Isan Lao Hui Wan, Cindy He Zhi, No Fatia, No Ishla, and Ong Hui Ru as group members. Do you know what is electrochemical sensors? Let me explain to you. Electrochemical sensors is basically a device that transforms electrochemical information into an analytical signal. The image shows that how analytical signals are being produced by electrochemical sensors via a series of electrochemical reactions.
An electrochemical sensor is a sophisticated device composed of several essential components, each contributing to its accurate operation. The first key component is the gas permeable membrane, allowing only specific gas molecules to pass through while blocking impurities and other substances. By controlling the diffusion of gases into the sensor, it ensures that only the target analyte reaches the reaction site, improving sensitivity and specificity. Beneath the gas permeable membrane lies the electrolyte, a liquid or gel-like medium essential for ion conduction. The electrolyte connects the electrons ionically, facilitating the redox reaction necessary for the sensor to function. It surrounds three electrodes: working electrode, reference electrode, and counter electrode, which are immersed in this medium within the sensing chamber of the sensor. The working electrode is the primary site of the redox reaction, where the target analyte interacts and produces an electrical signal proportional to its concentration. Positioned near the working electrode is the reference electrode, which provides a stable and fixed potential to serve as a baseline for accurate measurement. Completing the system is the counter electrode, positioned opposite the working electrode. This electron allows electrons to flow and balance the current generated at the working electrode, ensuring continuous redox activity. Finally, these components are connected to the transducer, an external part of the sensor that processes the electrical signals generated by the electrodes. The transducer converts this signal into a measurable output, such as the concentration of the target gas or analyte. Together, the gas permeable membrane, electrolyte, electrodes, and transducer work in harmony to make electrochemical sensor reliable tools for application in environmental monitoring, safety, and healthcare.
Now, I would like to explain about the types of electrochemical sensors. Basically, there are three main types of electrochemical sensors. One of them is called potentiometric sensors. This sensors is commonly being used to determine the composition of a sample through monitoring the potential difference between two electrodes. For example, this electrochemical sensor is commonly being used in analytical chemistry like pH meter, in which it can measure the hydrogen ions concentrations. Next, amperometric sensor is also a type of electrochemical sensor. It is used to measure the current flow between a reference and a working electrode. In the field of environmental monitoring, it is used in water quality testing, while in biomedical field, it is commonly being used as oxygen sensor to measure the oxygen level in the blood. Last but not least, conductometric sensor is one of the electrochemical sensors. Normally, this sensor is used to measure the conductivity of a film of material at a series of frequencies. In food industry, it is being used to check the concentration of salts and sugars in products like sauces and beverages.
To understand how an electrochemical sensor works, we can break it down into three main steps: diffusion, reaction, and signal generation. Each step is crucial for the sensor to function correctly and provide accurate results. The first step is diffusion. This is a process where the target gas or substance moves through the gas permeable membrane of the sensor. The membrane is designed to allow only specific molecules, such as oxygen or carbon monoxide, while blocking other unwanted substances. This step is important because it helps the sensor focus on detecting the correct analyte. The gas molecules that successfully pass through the membrane reach the electrode surface, where the next step begins. The second step is the reaction. When the gas molecules reach the working electrode, they undergo a chemical reaction, called an electrochemical reaction. Depending on the type of gas being detected, this reaction can be oxidation, where electrons are lost, or reduction, where electrons are gained. For example, if the sensor is detecting oxygen, the oxygen molecules might gain electrons to form a different chemical species. This reaction is highly specific to the target gas, which means the sensor is designed so that only the gas of interest reacts at the electrode. The reaction at the electrode produces electrons, which are critical for generating the electrical signal in the next step. The third and final step is signal generation. The electrons produced during the reaction flow through the circuits inside the sensor. This flow of electrons creates an electrical current. The amount of current generated depends on how much of the target gas is present. Higher concentrations produce more current, while lower concentrations produce less. This relationship allows the sensor to measure the concentration of the gas. The transducer inside the sensor takes this electrical signal and converts it into a form that can be read and displayed, such as a number on the screen. Together, these steps, diffusion, reaction, and signal generation, allow the sensor to detect specific gases or substances with high precision. By carefully controlling each part of this process, electrochemical sensors can provide accurate, reliable measurements that are widely used in industry.
The application of electrochemical sensors. First, we have smart bridge monitoring, which is often used to monitor corrosion in concrete materials. It can also measure other factors related to concrete structures, like surface potential, resistivity, noise, and galvanic current. These sensors can be connected in a wireless network for easier monitoring. Next, we have hydrogen sensors and detectors. The electrochemical sensors create an electrical current through a chemical reaction at the sensor surface. The sensor has two metal electrodes, anode and cathode, in a solution like sulfuric acid that lets ions flow between them. The electrodes are coated with a material like platinum to help the reaction happen. A membrane allows gases like hydrogen to pass through the sensor. The amount of current produced depends on the amount of gas, like hydrogen, present. This current can be measured to find out how much gas is there. Some sensors use a solid material instead of liquid to prevent leaks.
Application of electrochemical sensors. Electrochemical sensors play a crucial role in various industries by converting chemical information into electrical signals. Let's take a closer look at two key applications of these sensors. First, let's talk about the lithium-ion battery sensor. This sensor is widely used in battery monitoring systems, especially for rechargeable lithium-ion batteries, which are common in electric vehicles and consumer electronics. The sensor monitors several parameters such as the state of charge, voltage, temperature, pressure, and electrolyte levels. By doing so, it ensures the safety, performance, and longevity of the battery. These features are particularly important due to the high energy density and power demands of lithium-ion batteries, as well as their environmental impact. Next, we have the carbon monoxide sensor. This is a high quality sensor that is highly sensitive to detecting carbon monoxide gas. It's designed to ensure safety by providing real-time monitoring of carbon monoxide levels in the environment. In summary, electrochemical sensors like the carbon monoxide sensor and the lithium ion battery sensor are vital in improving safety, efficiency, and environmental sustainability in their respective fields. The applications highlight the importance of technology in enhancing everyday life and industrial process.
Next, I would like to explain about advantages of electrochemical sensors. The first advantage is remarkable repeatability and accuracy. This means that when gas enter the transducer, so the known gas concentration can be calibrated and electrochemical sensor can accurately measure the same gas repeatedly. So this makes the electrochemical sensor dependable for monitoring the gas level in various applications. Second is fast response time. Electrochemical sensors provide rapid detection of target substances, normally within seconds, and making them suitable for real-time monitoring. The third one is practical and economical. So electrochemical sensors are generally less expensive to manufacture and maintain. So compared to the photoionization detector, PID, which can also detect the same gas as electrochemical sensor like ammonia gas and hydrogen sulfide, PID is 3 to 5 times expensive than the electrochemical sensors, or even more. So the last advantage is compact and portable. The portability is very important because it allows the easy field monitoring, rapid deployment in emergencies, and even the personal safety monitoring in workplace.
Limitation of electrochemical sensor. The first limitation of electrochemical sensor is short or limited shelf life. Depending on the target gas and the environment, an electrochemical sensor has a shelf life of 6 months to 1 year. The second limitation of electrochemical sensor is limited or confined temperature range. Temperature is a big factor for electrochemical sensor, and they are sensitive to the temperature, and therefore the sensors are internally temperature compensated. The last limitation of electrochemical sensor is cross-sensitivity of other gases. Although this is an advantage, it tends to be disadvantage too. Some sensors are subject to interfering with different gases. To avoid potential false reading, it is important to know what gases cause interference with the sensor. These are the references we refer to do our assignment. Our references consist of scientific website and journal.
That's all from us. Thank you.